Bismillahir Rahmanir Rahim. Alhamdulillah wa salatu wa salamu ala Rasulillah wa ala alihi wa sahbihi wa mawala wa ba'd. Assalamu alaikum wa rahmatullahi wa barakatuh. All praise and thanks are due solely to Allah subhanahu wa ta'ala. Choices, peace, blessings and salutations upon our master and exemplar Nabi Muhammad sallallahu alayhi wa sallam. Ahlan wa sahlan wa marhaban bikum. I welcome you to the Isnad Academy. We are coming to you live on the radio station Voice of the Cape, on YouTube as well as Facebook, on various platforms, of course the Isnad Academy platforms. We do have a problem with our Isnad Academy YouTube channel at the moment. So unfortunately we're not broadcasting there, but we are broadcasting to the Facebook page. So ahlan wa sahlan from whichever platform you're joining us on, whether that be on the radio airwaves or online. We welcome you all. Tonight's discussion, bi'idhnillahi ta'ala, will be about the vaccines in the light of science, of course, the science around vaccines. And we are only dealing with our scientists this evening. Mufti Taha will not be joining us because we have covered basically everything we need to cover as far as the Sharia is concerned. Alhamdulillah. So we are now going to focus our attention on the science around the vaccines. And of course, we've heard that the vaccines have rolled in already and the program is about to start. So now the information becomes even more pertinent. We are so privileged this evening, alhamdulillah, to have experts in their fields, some of the leading experts in their fields from our own communities now, mashallah. So I will introduce them in a moment, but let's officially kick this off with our official introduction. And after that, we'll immediately commence, inshallah. So with us tonight discussing some of the scientific facts that we need to know is Dr. Tasnim Suliman. She is an associate lecturer in virology at UWC, that's the University of Eastern Cape. She's now working in close collaboration with the Division of Medical Virology at Stellenbosch University, where she previously held a post-doctoral fellowship. She has also done her PhD research on the SARS coronavirus of 2002, the epidemic that took place then, at the Institute of Virology in Bonn, Germany, where she trained in the lab of the European expert in coronavirus research, Professor Christian Drosten. Then, alhamdulillah, we have Dr. Shameem Jaumdally, who we also had the privilege of meeting him and learning from him. I think it was on Friday night, alhamdulillah. He's a senior researcher at the UCT Lung Institute who trained in medical virology, immunology, in which he has his PhD, as well as epidemiology. Normally they work on tuberculosis, but since the start of the epidemic, they focus their attention on COVID-19. Of course, Dr. Tasnim also she's known as one of the scientists in the world, definitely the first in South Africa, to have actually isolated the virus, and she will tell us more about that, inshallah. So now I'll bring my guests up in the studio. First and foremost, our very own, and this is why I'm not introducing him as a guest anymore, he's almost like a co-host now, alhamdulillah, to these programs. That's none other than Dr. Salim Parker. Dr. Salim, assalamu alaikum wa rahmatullahi wa barakatuh.
Alaikum salam wa rahmatullahi wa barakatuh. And shukran once again for this very informative program, which I think is absolutely needed. And just from the attendance at the previous ones, I think we are impacting and making a voice about what the science is as far as coronavirus disease is concerned.
Barakallah fikum. And of course, Doc, you saw I didn't give you a very formal introduction because I think our guests, our viewers at least, they've met you many times before, and you are our community doctor as well, GP in Elsies River for many years. And subhanallah, and I'm making sure to mention that because every time I mention Doc's other credentials, then he always reminds me, most importantly, I'm a GP in Elsies River, alhamdulillah, but also an expert in travel medicine and an expert reviewer of certain medical journals, including ones pertaining to vaccine. And as I said before, Dr. Tasnim Suliman, in some circles, the famous Tasnim Suliman, in other circles, the infamous Dr. Tasnim Suliman. Jazakumullah khairan for joining us this evening. I hope you are well, inshallah.
Walaikum assalam wa rahmatullahi wa barakatuh. Thank you for having me, and it's a pleasure to be here. I hope I can do justice to this platform. And I'm a bit curious to why I'm infamous, but I just keep my nose down and I just do my lab work and I go on with it.
Yeah, let's just remain curious about that and not go any further into that one there. And then, of course, you have Dr. Shameem Jaumdally. Ahlan wa sahlan. Assalamu alaikum wa rahmatullahi wa barakatuh. Dr. Shameem, I think you are on mute somehow or the other. We don't get any sound from you at the moment. But while you're getting your sound sorted, inshallah, You can just speak when you're ready, and then I'll know that your sound is there. We will move on immediately to questions since we have such a jam-packed program this evening. Of course, we are in a very important time. We find ourselves in a very critical time, and everybody now needs to make this big decision, and people have the right to know. People are interested, they're curious, they want to know for their own sake, their own benefit, about the ins and outs of the vaccine. So Dr. Salim, let's kick this off with yourself. How vaccines really work, how are they of benefit to humankind? Is it in fact a victim of its own success? Bismillah, Dr. Salim.
Yes, I mean, I consider vaccines to be a victim of their own success, and I think that's why the resistance and the apathy and also the what's called the vaccine hesitancy is arising currently. But let's take a step back. I mean, a common cause of death, and in previous centuries, last century, but also in certain third world countries, the commonest cause of death are infectious diseases. So now let's look at what vaccines have done. And we know that as far as prevention of death is concerned, vaccines, the provision of clean water, and of course antibiotics has been the major sources of children, for example, not dying at birth or at a young age. And just to put it in perspective, currently the World Health Organization estimates that 2 to 3 million deaths are prevented due to vaccines every single year. 2 to 3 million deaths. We're not even talking about damage, for example, brain damage due to polio or paralysis due to polio. We're talking purely of deaths. Are we doing enough? No, we're not. It's estimated that another 1.5 million deaths every single year can still be prevented if everyone who needs to be vaccinated actually has that provided for them. So, this sounds like figures, but let's look at real examples. I mean, we know all our kids have been vaccinated against measles, for example. Now, of course, whenever we look at any a vaccine, we're looking at the benefits, and then we also look at the side effects, or what we call the risk of giving the vaccine. And measles is a clear-cut example. It's been estimated that if you look at the last 15 years, 12 million deaths have been prevented. Some people say even 17 million, but let's use a lower figure. 12 million deaths have been prevented due to vaccinating children against measles vaccine. What are the known side effects? How many deaths occurred due to the vaccine itself? In a 10-year period, only 6 deaths have been documented. People always say this person had the vaccine and then he passed away 2 days later. But if there's no proof that the majority of those allegations have been associated with the vaccine itself. So if we consider measles only, over a 10-year period, 6 deaths due to the vaccine itself, because it's a live virus that is used in the vaccination. Let's look at another example. Polio, everyone knows about, but no one has seen it. Why? Because over the last 40 years, every year about 140 million children are born. Virtually all of them are vaccinated against it. And it is estimated that more than 15 million deaths have been prevented due to using the polio vaccine. But we don't see polio disease anymore. But what do we see? We see the side effect of the vaccine. And this is specifically due to the oral polio vaccine, which is called the live attenuated polio vaccine. Now, what happens there is that the virus mutates if there's not enough immunity in the community. And what do we see? We're preventing millions of deaths, but we're seeing about 400 of these what you call vaccine-acquired infections of polio globally on every single year. At the moment, the vaccine is so effective that we're seeing less than 200 cases of the of the disease itself. So we're seeing more effects of the vaccine than of the virus itself. But the reason for that is over a 40-year period, virtually every single child has been vaccinated. Now, if there's a problem with vaccination, and this happened, for example, in a country like the DRC, the Democratic Republic of Congo, at the beginning of last year, there was an Ebola outbreak, and then, of course, they had COVID as well. So the measles campaign and vaccination was stopped and interrupted. And what resulted from that? 6,000 children died. Preventable. This could have been prevented if these children got the vaccines. So this is clearly a case of there's very little of the disease because we're doing so well with the vaccines. We're seeing more and more of the vaccine side effects, but we're seeing that because we're vaccinating 140 to 130 to 140 million children every year, preventing millions of deaths every single year. And we're seeing a small number of side effects, which are there. It's real. Now, if we are saying, do we have to vaccinate every child against every single disease all the time? Say no. Sometimes, for example, in the case of cholera, and our older Hujjans who went maybe 20, 30 years ago will remember that they were vaccinated against cholera. That was part of the vaccine schedule that time, so that they don't get cholera and don't bring it back to South Africa. So, but what happened lately is that there's clean water in Saudi Arabia that prevents cholera from being transmitted, and therefore we don't need to give cholera vaccinations anymore. Similarly, if we look about the vaccines that we give our Hujjaj, we all know that we have to take meningococcal vaccine, the meningitis vaccine. So what happens is that this particular, it's a bacteria, not a virus, actually came from sub-Saharan Africa. We call it the meningitis belt, which is Senegal in the west to Ethiopia in the east. Now, every single year there's epidemics of meningitis there. And what the World Health Organization then implemented was to have every single child vaccinated against one particular type, which is called serogroup A, but let's just call it meningitis vaccination in sub-Saharan Africa. And from seeing 250,000 cases in one particular year with 25,000 deaths, and also about 50,000 children either going deaf or being paralyzed over the last few years, because of vaccination, guess what we're seeing? Certain countries, not a single cause of meningococcal meningitis, solely due to the success of this particular vaccine. And lastly, just to emphasize the point, since we started pneumococcal, which is the bacteria causing pneumonia in children in South Africa, before we started vaccinating, we had over 100,000 hospitalized children every single year with about 5,000 deaths. After vaccination, we're seeing less than 50,000 hospitalizations with less than 2,000 deaths. So a percentage drop of more than 50% solely due to the benefits of vaccination. And that's why I want to put it in perspective that worldwide the benefits of vaccination has been proven. Yes, there are always going to be certain ones that don't work well. The AstraZeneca one is a case of point where initially it was thought to work well in South Africa. Then because of mutations, there was a problem as far as its efficacy against mild disease is concerned. But the science was open to it. It was going to be rolled out, but because of its limitation, it was held back and another vaccine was brought into its place. So vaccination, when we look at it, we look at the benefits compared to the hazards, but the benefits in the vast majority of cases far outweigh the risks of taking the vaccine. I think that I want to start that off as an introduction.
Shukran very much, Dr. Salim. That was an excellent introduction, very insightful. The statistics there does provide quite a bit of clarity for Alhamdulillah. That is something that I was actually taken aback by, the approach to the AstraZeneca thing. Like I said previously, it would have been quite an easy move to just say, you know what, we need to save face here, we're already going through this thing. But as soon as a problem was discovered, regardless of the name of that problem, matters were reversed. And this shows a level of honesty and clarity, at least to myself. Dr. Tasnim, again, welcome to our panel. It's an honor and a privilege to have you with us. Alhamdulillah, you are still mute, by the way. We do understand that you have worked with coronaviruses for a long time. One of your specialities is being able to grow them in a lab. It was actually interesting when I met you, when we spoke on WhatsApp. You told me you were into coronaviruses long before they became popular. That is an interesting way of putting it. So could you tell us a bit about this, why it is important, and also how this could affect vaccine development? Maybe even just a bit about your journey in achieving what you've achieved with regards to this current virus. Bismillah.
Okay. Bismillahirrahmanirrahim. That is a loaded question. And when you ask someone about the love of their life, they will naturally go on talking for hours. Unfortunately, I don't have the luxury to do that, but coronaviruses definitely are the love of my life. I hope my husband didn't hear that. But anyway, moving along. Wow. Okay.
We should
Coronaviruses for
actually
all practical
clarify. We should qualify your statement, right? The study of coronaviruses.
potato,
People will.
potato. Okay.
Bismillah.
So uh, people have asked me when I undertook studying coronaviruses, did I ever foresee a pandemic of this nature? The answer is no. In fact, I had no idea what was coming. I had no idea what I was getting myself into. And it sounds a bit, I don't know, I don't know what the word is. It sounds a bit like cool when you say like, oh, I've been growing viruses in the lab, but that just rolled as part of the study that I needed to do. So basically, when it comes to virus culture, I'd just like to explain a little bit about it. What it is that we take a sample from a patient and we put it into what we call cell culture, as in onto in a dish that has cells growing inside it. And the reason for this is that unlike bacteria, which can grow on surfaces and outside of cells, viruses need to get inside a cell in order to be able to replicate and reproduce and proliferate. So that is one of the fundamental differences between viruses and bacteria, and also which contributes significantly to the complexity of viral disease, firstly, and also any kind of laboratory technique. So that is, I call virus culture pretty much an art because there's no one size fits all for every kind of virus that there is. And also, when people spread the negative impression that, oh, we're growing viruses in the lab, it's this big bad thing. It's not. Like 20 years ago or around then or even longer, growing viruses was one of the ways of diagnosing them. So virus culture was a diagnostic technique. Now we have these fancy molecular platforms that can do high throughput analyses, and we are able to diagnose viruses in a much less, in a much safer way. Let's just say. Also, another point about virus culture is that it's a highly sensitive process. Like I said, there's no one size fits all. Like one cell line, like one type of cell, for argument's sake, may not work for one virus, but it may work very well for another. For example, influenza grows well in chicken embryos. So basically, it'll be like a chicken egg that grows influenza, but that will not work for SARS coronavirus or any of the coronaviruses. There are very few viruses that can be grown in that way, simply because of the genetic makeup of the virus. Even though it may look like influenza and SARS cause the same kind of symptoms, they affect the respiratory tract, etc., they're entirely different in how they grow, in how they replicate. And basically, one of the problems with this pandemic at the moment is that we are chasing a moving target. And that was something that came to mind when Dr. Salim commented on the AstraZeneca vaccine. The target simply changed. And with viruses and mutations, we don't know what's coming next. And I don't think the world has ever faced a pandemic of this nature. Therefore, we're seeing mutations at a rate that is not common for coronaviruses. Coronaviruses, although they have one of the largest RNA, in fact, the largest RNA genomes, which means it is about 3 or more times larger than the genome of influenza. That makes it more complicated. So basically, there's more room, should be more room for error. However, influenza is far more likely to, it's far more prone to mutations than coronaviruses. I'm not going to get into detail with that because that's a very interesting subject for me. However, the mutation rate for coronaviruses is incredibly low. That's why some HIV virologists in our department have even commented that it's a very boring virus at the genetic level because we don't see mutations often. Which is why this mutation kind of surprised me. Initially, I didn't take it seriously until I saw the data and how it was actually outcompeting the previous strain. And also, I'd like to add that the reason we found, South African scientists found this strain is because we were looking for it. We were actively surveying, but I'm willing to bet that there are many more strains around the world that may or may not have this level of severity or that may not be this significant, but there definitely are multiple variants out there. Oh yes, I would like to also clarify that we can't really call it a strain as yet because we haven't done the necessary analyses to be able to prove that this virus, that this variant, the 501YV2, we haven't proven yet that it has enough changes as compared to the first wave virus that can call it a strain. we have to be able to see a functional difference in order to be able to label it as a strain. So for now, let's just stick to the nomenclature of it being a variant, although it's very easy to slip into, it's just to slip with the nomenclature. However, those are my sentiments right now, the fact that the virus is a moving target. And to be honest, growing this virus was a little bit more difficult than the first wave. I don't know why, but I'm not the only person who struggled. Apparently, the scientists at the Africa Health Research Institute also, it wasn't the easiest thing for them to do, and they also had to try a few tricks and things that were not common for SARS coronavirus culture. So I was very surprised when one of my samples actually worked. So at the moment,
for the public, often the expression growing the virus is like, oh my God, what are they doing? Subhanallah, it sounds really scary. See Dr. Salim laughing over there. So could you just clarify in the simplest of terms, what is, why is this not something scary? I know you did explain it, but for the person sitting thinking, she's talking about growing the virus.
I'm going to make it super simple. It's like farming. If you put a seed, like out from an apple, if you take a kernel and you put it into the ground and you let it grow, that is what we're doing. We're basically mimicking the human body environment in the laboratory to allow this virus to grow so that we can have a pure culture with which to do research. I also have to emphasize that a pure virus culture is absolutely fundamental for any kind of development of any antiviral drug or vaccine. Without this, we can do nothing. We will never know the first phase of how does this virus react in the lab. What is the dose of whatever antiviral drug we're going to use? Where do we start? This is a starting point. Without this, it is virtually impossible to do any kind of research that will lead to any kind of definitive therapy. So it isn't something dangerous. It requires obviously certain conditions and trained personnel and skilled scientists, and also the absolute use of a biosafety level 3 laboratory is mandatory for this coronavirus. It's a safety level 3 organism, so it's a risk group 3. Let's just call it that. So there are certain requirements and rules and regulations in place to make sure that the personnel working on it are safe and the public are safe from any kind of mishaps and accidents. And in any case, you're more likely to get the virus out there in the world, going to the supermarket, than you are in the actual laboratory because of the kind of safety gear we work with. And also, if you look at it, each person who has COVID-19 is actually a culture vessel. So what we're doing in the lab is not very much different from having a person sitting next to you being infected with the virus.
Okay, awesome. Shukran. I see Dr. Shameem must have accidentally just left there. I am going to take this point. Okay, he's back. Dr. Shameem is back. Assalamu alaikum, Dr. Shameem. I see you accidentally left us there for a moment. I'm going to take this moment before we move on. I see we have, as we normally do, we have comments. Sometimes the comments are genuine questions. Sometimes they are people seeing links. Sometimes people get a bit rude and so on. So let me just, at the outset, lay out some ground rules. Any questions are welcome, regardless of how critical the question may seem. Rude comments will not be tolerated. You will be warned by getting your comments deleted initially, and then you could get kicked off as well. Some of the questions have been covered already. I see Brother Faiz Ibrahim started off with a very straightforward question. Will the vaccine protect one from getting COVID? So I'm going to address to Dr. Shameem, but then the same question, well, somebody says my question as well. And then the same question goes on and he says, and is it halal? Now, this is something we've covered extensively in the program with Mufti Karan. So you're more than welcome to go and revisit that particular program there. And then the comments seem to be getting a bit personal. So this type of comment will not be tolerated. Asking a particular person, I'll show the comment and show you this. This is why I think this particular type of comment is not acceptable. This is now directed at a person and their family, as opposed to as opposed to being a genuine question. So yeah, please refrain from doing things like that, and we will have to ask you to specifically keep them as questions, as critical as they may be, bi'idhnillahi ta'ala. Dr. Shameem, here's one for you, inshallah. We are now getting the Johnson & Johnson and Pfizer vaccines. How do they differ from the AstraZeneca vaccines that we were getting before? Could you shed some light on that for us? Bismillah.
Bismillah. Assalamu alaikum. Can Maulana hear me?
Yes, we can hear you loud and clear. Bismillah.
Bismillah. Yes. So, do you want me to first address the first question that you put up on the screen?
Yes, I think so. Let's start off with that, inshallah.
Okay. Can you put back the question on the screen for everybody to see and?
Sure, absolutely.
You have it. Okay. So the question there is, will the vaccine protect one from getting COVID? The question can be interpreted in different ways based on what people call COVID, right? So I'm going to answer the question in two ways. The first question, I'm going to break it down into two questions. Can the vaccine protect one from getting an infection? And can the vaccine protect one from developing diseases if they do get the infection? So for the first one, there are certain vaccines that have already shown efficacy, where 2 out of 3 people who received it were actually protected from being infected. So these types of questions are much harder to answer because I was expanded on, I think before in one of the talks, to be able to make inferences and to make supposition about the general population, you need to have a sample size that is big enough to answer certain questions. So for the first one, there is only one vaccine, I think, so far that has shown to be protective against the infection. And in the second part of whether it protects against disease, there are 2 answers to that as well. So some of the vaccines have shown efficacy against, the development of mild and moderate disease. And these vaccines have also shown efficacy towards protection against the development of severe disease that eventually leads to hospitalization and death. And more vaccines, though, have actually shown efficacy towards the prevention of development of the severe disease that leads to hospitalization and death. So to answer the question in a simpler way, yes, the vaccine has so far been efficacious against the development of severe disease. Some of them have not shown efficacy against the development of mild to moderate disease. But again, I want to repeat, the ultimate goal of the vaccine is to prevent the development of these severe cases that we see right now and the death that it's causing. I hope I've answered that question. And now to move to Maulana's question regarding the differences between the AstraZeneca vaccine, which is the one that was first planned for rolled out and that has since then been shelved, and the Johnson & Johnson and the Pfizer vaccine that we are now getting. And I understand that for the Johnson & Johnson, the rollout is happening tomorrow. The healthcare workers are going to start getting the jab as from tomorrow. So with regard to differences, the Johnson & Johnson and the AstraZeneca vaccine are actually very similar. They are similar in the type of system that they use, which is the adenovirus vector that carries that piece of genetic material to then teach your body to make these proteins and to develop immunity against the proteins and eventually the virus when we do encounter them. And also in the target that the vaccine is actually using, which is the envelope, the spike of the virus, right? The only difference between the Johnson & Johnson vaccine and the AstraZeneca vaccine is that for the AstraZeneca vaccine, the virus that has been used as the vector, as the carrier, as the transporter for that piece of information into our cell comes from a chimpanzee. Whereas the virus used for the Johnson & Johnson vaccine is one that has been isolated from human. So the one is a virus that we know is commonly found in chimpanzee, and the one that is using the Johnson & Johnson is one that is commonly found in human. And at the end of the day, There have been studies that have evaluated the difference in terms of the immune response, in terms of the toxicity, in terms of the safety for both of these vectors on their own. And there has been no difference. And the short answer is they're both safe and they both work and do the job that we want them to do. All right. So that's the only difference between the Johnson & Johnson and the AstraZeneca vaccine. That I'm talking about the constitution now. We'll go to the dosage after that. Now for the Pfizer. The Pfizer is a more modern system of vaccine that is being put in use right now. So basically, for the Johnson & Johnson and the AstraZeneca vaccine, we know that they use a virus to carry the piece of information into our cells. And these further need to go inside our nucleus to be able to be expressed and produce the protein. But what the mRNA system does is, instead of using that vehicle, that capsule of the virus to get inside the cells to train the cell to make the protein that will elicit and that will make the immune response that we desire out of a vaccine, the genetic material and that information in the Pfizer vaccine is actually put inside a bubble of oil, which is what we call a lipid membrane. And the reason why they use this is because our cells, each and every single one of our cells, has that same outer coating of lipids, of phospholipids. So when we use that system to carry something into the cell, you can understand that because they are alike, it represents an easier way of transferring everything that we want into the cell. So this is one thing that has already been shown, that the efficacy of the transfer of this material inside cell using the new system is better than the one where we're using a virus, right? And on top of that, the moment it enters the cell is the moment our cells start producing these protein, these spikes of the virus that we need to cause the response that we are asking and coding for to develop immunity. So in a sense, the mRNA vaccine from Pfizer is one that produces the immune response that we want faster. It is a system that is a little bit easier to manufacture even. The only problem that we have with this vaccine is that because it's using an mRNA system, this is not as stable as the DNA that we use in the Johnson & Johnson and the AstraZeneca vaccine. This means that we need very cold temperature of up to minus 70 to 80 degrees to store the vaccine before it's actually administered into people. But at the end of the day, the target and the end goal of each of these different vaccines remains the same. It's to elicit a response to the envelope of the virus and to give our immune system a picture of what the virus looks like, so that when we do encounter the virus, it's already aware of the impact that the virus can have, and it will kick into gear and send out the soldiers that are the most competent to fight the virus.
Jazakumullah khairan. So yes, this is what happens. You ask for scientists and you get science talk, alhamdulillah. And we appreciate that, because we really need to get our facts straight, especially now. This is really important for all of us. I do want to note all the questions of the viewers. There are quite a few questions, some really good questions that have come through. We will try our utmost to get through as many of them as possible. So I'm going to ask our panelists, while we don't want to rush you, we also want to keep the answers nice and brief, inshallah. Dr. Salim, who's still on mute at the moment, the next question is for yourself. What was the experience like in the rest of the world so far with regard to the COVID vaccines? Now, before you answer that, I find it very sort of reassuring that in the way that the vaccines were rolled out, that we could see it performing in other countries, especially the more affluent Western countries, because I think there were many sentiments going around about how this is going to be for depopulation and it's going to be to get to kill off people and so on. And as ridiculous as that may sound, at least we'll see it with them first. So tell us, what was the experience like of the rest of the world? Bismillah.
Yeah, okay. Bismillah ar-Rahman ar-Rahim. Well, let's look at where the current rollout is going on at quite a rapid pace. 52 million doses of it has been used in the United States so far. So, but there's not a lot of science coming back yet, because it's a progress in motion at the moment. But what we do have is, of all countries, Israel has got very good data at the moment. It's one of the countries which has vaccinated a significant percentage of the elderly population. And the figures that we see coming out of Israel is actually quite reassuring as far as the vaccine is concerned. And if they're going to be depopulating any country, it seems that Israel is going to be the first one, because they're rapidly moving to vaccinating most of the adults in that country. But the figures are staggering. They've looked at about 500,000 people were vaccinated. That is a big number. I mean, Shameem was earlier referring to sample size. You can't get bigger than a sample size of 500,000 that you could refer back to. And it was shown that the vaccine is 93% effective. And of that 500,000, it's actually 520,000 cases that were vaccinated. None of them died. And they were followed up for a few weeks. And there was only about 4 hospitalizations. That is a staggering figure, efficacy of about 93%. And if you look at the number of people who've been vaccinated in Israel at the moment, out of a million, the population is about 9 million. They vaccinated close to 3 million already. So they've got good data coming out. And another good study that they did, this is an observational study. In other words, they vaccinate people and they follow them up for a few weeks, and obviously they're going to months and so forth. And they looked at the last month, ending in about the second week of February, and there was about 1,500 deaths due to COVID-19. And of those, only about 1% of the people who were vaccinated passed away due to COVID-19. All the others did not receive the vaccine. So that clearly shows that the vaccine is efficacious. And this, again, shows that the disease pattern in Israel is shifting, where we all know that in all other countries throughout the world, even in Israel, initially it was the elderly people who were hospitalized, it was the older people who got more severe disease. But now, because they're vaccinated, who do we see hospitalized in those countries? The younger ones, not having been vaccinated. So the pattern is changing, because the vulnerable population is now the younger ones. They're getting less numbers sick, but because it's such a big country, 9 million people, they are seeing the younger people being hospitalized. And the ratio, where previously most of those in hospital were over the age of 50, now more than 50% in hospital are under the age of 40 or 50 years old at the moment, clearly showing the benefits in a country such as Israel.
Now, Doc, we spoke about this briefly before, but it's an important point because it keeps getting brought up. We saw a report of about 30 or so deaths in, I think it was Norway, where after receiving the vaccine, people died. And of course, for many people around the world, this was like alarm bell ringing. Can you tell us, what's the update on this? Was this as a result of getting vaccinated?
Okay, the 23 elderly people in old age home passed away in Norway, and this was after they received the vaccines. But remember, people in old age homes are passing away on a daily basis. So when they looked at the overall number of deaths, and this is from the World Health Organization as well as the Norwegian health authorities, when they looked at the total number of deaths of elderly people in old age homes, the percentage of those who passed away who had the COVID-19 vaccine was similar to the overall picture. In other words, if 1% of old age residents pass away per month, those who were vaccinated, the number who passed away from it was 1%, and in the overall scheme of things, those who were not vaccinated, the overall number of deaths was also 1%. I'm using a thumbsuck percentage, but the figures were the same, whatever they were.
Okay, shukran very much.
No, this is where also comes in. Newspaper, but 3 people died. Very few reported 2 days later when these statistics came out about the fact that it was not beyond the normal limits of people dying in old age homes.
Okay, shukran for that, Dr. Salim. Dr. Tasnim, this one is for you again. Vaccines have been around for many decades, right? And many of us have taken vaccines. We send our children to get vaccines, especially our very young children, infants, and so on. Or perhaps when we travel, right? So why don't any of these vaccines help against the coronavirus?
Okay. Viruses are vastly different in and of themselves. Like, for example, just as I illustrated earlier, the influenza virus is very different from the SARS coronavirus. And as we've seen, even in this pandemic, the first variant versus the second variant is quite different. And we're seeing a difference in vaccine efficacy and efficiency between these two variants, for example. So there is no one-size-fits-all solution. In fact, when SARS of the 2002 outbreak occurred, or it came out, people suddenly took notice of coronaviruses. And then there was a lot of research and funding put into coronaviruses, and then suddenly it disappeared because of good quarantine measures at that point. So there were like 8,000 cases worldwide and only 10% of deaths, approximately. In the space of under a year, or approximately a year, if I'm not mistaken. I stand to be corrected on that. But what I'm getting at, it was a relatively short period of time, and it was nowhere near what we are seeing with this pandemic. However, viruses are vastly different. Measles, for example, has a completely different genetic makeup to, for example, the coronavirus or influenza or anything else. And so basically, every new virus that comes out is basically a new target. Even now, with the SARS coronavirus 2 that's around in this pandemic, we don't know what's coming next. We don't know how the virus is going to mutate next, and we have absolutely no way of knowing. It doesn't mean that scientists are not doing their jobs. It means that this is literally a moving target. So, yes, people have revisited old vaccines, and at the time when SARS coronavirus of the 2002 epidemic, at that time it wasn't a pandemic, when that occurred, there was some efforts at vaccine development that were made then, but they quickly died down because of at that time it wasn't widely spread enough, and it didn't make financial sense to put so much more effort and research and resources into a virus that didn't look like it was coming back for a long time. It's been like more than a decade, and then it resurfaced in a different form. It's closely related, but not exactly the same. That's why the name SARS coronavirus 2 and not 1, because it's significantly different to the first one. Also, people have looked at, scientists have also looked at when MERS coronavirus came out, the Middle Eastern Respiratory Syndrome coronavirus in 2012. That was when people suddenly got a jolt because it was causing deaths. And although maybe I should just clarify, there are 7 known human coronaviruses at this stage. Coronaviruses also infect other species, for example, bats. Bats have a multitude of coronaviruses that they carry. It was a very interesting point of my research during my postdoctoral fellowship at Stellenbosch University. However, we moved along to the human coronaviruses when this came along. But sorry to digress, but just to reiterate that there's a lot of coronaviruses out there, and the human coronaviruses are 7, 4 of which cause mild disease. I've had a laboratory confirmed infection of one of the milder ones many years ago, and it didn't cause anything more than a running nose. And many people have had it also. This was proven by serology, like among students. There was a brief small study done for someone's student project in which they took blood from several university students, and they looked for previous exposure of this infection, and there were many of them who had it, if not all. This was one of the milder ones. However, when a MERS coronavirus came out, people suddenly started to think maybe we should look at a one-size-fits-all solution for coronaviruses. And that means we should look at what we call a conserved region, which means a genetic piece, a piece of the genome of the virus that is the same in all coronaviruses. So efforts have been made at looking at targets, gene targets, as in for vaccines that are conserved among coronavirus groups. However, that hasn't been met with a lot of success because obviously the viruses are so vastly different. And now because it's a pandemic, we need to make concerted effort at honing in on this particular target, if it makes any sense.
Shukran so much. Yes, it seems like there's really a lot of information here and so many more questions to get through. Dr. Shameem, we've discovered that the AstraZeneca vaccine was not going to be effective on the South African variant, and excuse me if I'm not using the correct terminology here, but I can't be held to task because I don't have the qualifications you have. What's going to happen should there be further mutation down the road? What's going to happen with the efficacy of the vaccines that we currently have? How is this going to be impacted?
Right. So first, I want to describe very briefly why this affects vaccine efficacy. While the virus is mutating, what it's causing is a change in the way it looks, right? And the way we use vaccine is to teach the immune response, the immune system, what the virus looks like and how to fight it when we do encounter it. So you can imagine while the virus is changing, it's basically disguising itself. And the more we allow it to replicate, the reason why this happens is because more people get infected, the greater the risk that it will develop mutation that will render it what we call a fit. We call that a fitness in virology and in science, which means that it makes the virus a little bit better in the way it works, in the way it replicates, in the way it's transmitted, not necessarily in the way it causes disease. So while this happens, the vaccine is not going to work anymore because if we're using that vaccine, we are training the immune system to recognize what the virus looked like before, right? So what it eventually means is that, as Tasnim put it, and as Salim put it like numerous times before, the target is always moving, which is why we need to act fast. The more the virus changes, the more the likelihood that we actually need to change vaccine to be able to keep toe-to-toe with this virus until we eventually manage to eradicate it. And right now, as of yesterday, there is a new effort that has been started where instead of using the envelope of the virus as one of the target, if not the only target of all the vaccines that have been created right now, scientists have tried a combination of the envelope and what we call the nucleocapsid. The nucleocapsid is basically like a sphere inside the virus that contains the genetic material of the virus. So if we manage to develop and train the immune system to develop a response to not only the envelope that is changing constantly, but if we can teach the immune system what something like the nucleocapsid that doesn't change as much as the envelope, if we teach that immune system to know what that nucleocapsid looks like and how to fight it, there could possibly be a greater efficacy over a longer period, in the sense that even if the virus is changing, it's not changing in that place that it's weakness in terms of the vaccine usage now. So that's one way of tackling it. The other way is to use the seasonal flu vaccine example, where we will get to a situation where we will have to collect some of the most prevalent variants of the actual virus SARS-CoV-2 right now around the world. One in the UK, one in South Africa, one in Latin America, one in Asia. We put that in one vaccine and we train our immune system to recognize what all of them look like, so that if we do encounter any one of them, our immune system has a compartment, or like, a special army to fight against each one of these viruses. And I think this is probably where we're heading right now, as long as we have mutation in the virus.
Okay, Jazakumullah khair. And I think we need to just break from our regular schedule. Dr. Salim, if you will, bi'idhnillah, I would like to just address some of the comments from the community and from the viewers and listenership, inshallah ta'ala. Dr. Salim, you are on mute at the moment, so while I get to those questions, Bismillah. Why is there no vaccine for TB, HIV? Those are major diseases in South Africa. Are they not important?
I think Dr. Shameem will be able to answer that, but basically, it's a contest between the human being, what we know, and also how the virus adapts to it. And I classically like using malaria as an example. Kills 500,000 children in Africa on a daily basis. The parasite is able to adapt. For example, we used to use chloroquine, which was used initially in the treatment of COVID-19 in Africa, and it was very, very effective in actually curing people who had malaria. But the parasite developed resistance to it. And similarly, then we use other medications which currently are quite effective, but there are areas in the world where for example, in Southeast Asia, where even the most potent antimalarial drug to treat is the parasite is developing resistance to it. So as far as HIV is concerned, whatever has been developed, there seems the ability of the virus to be to adapt to it and to escape the immune boosting mechanisms that we're actually using in the vaccine itself. Having said that, unfortunately, compared to, for example, for COVID-19, where so much money was poured in, all the best resources were used to develop these vaccines. As soon as there's a good development in any of the subjects, there's not a lot of interest by big pharmaceutical companies, by Western countries, for example, to pour more money into there, because it's not really to their benefit. And then the interest comes and it wanes, and by the time there's some promise in for example, the TB vaccine, so much the bacteria in that case has developed some resistance to that, and the whole process has to start again. So if you really want to get a good vaccine against TB or against HIV, pour money into Dr. Shameem's units, because they are doing groundbreaking research. But unfortunately, it doesn't always amount. It doesn't always. It's not nowhere enough to what they need. And the same applies to Tasnim's unit as well.
Okay, shukran, Dr. Salim. Dr. Shameem, there's a question, and this one frequently showed, actually, there are many ladies who have concerns about breastfeeding, pregnant women, as well as for parents who still want to conceive in future. Are there any repercussions or side effects that we know of with regards to the vaccines? Bismillah.
Yes, so basically, when we were doing the trial, which was a phase 2 trial of the Novavax vaccine and the AstraZeneca Oxford vaccine, one of the exclusion criteria was being pregnant or actually planning to be pregnant over the course of the study, which was around a year. And right now, to be honest with you, I am not clinically trained. I do not know for all of the different specific vaccines whether they are recommended or not for women who are pregnant or who are planning to get pregnant or who are breastfeeding. But as I understand it, the first batch of the vaccine that will be rolled out in South Africa and in a lot of different places for that matter will first be rolled out in the healthcare workers. So while we wait for more data along the lines of safety for women who are pregnant or who are planning to get pregnant or who are breastfeeding come out, we will be using the group of vaccinees as Salim put it earlier as a very good like a life-size example of the safety profile for the vaccine and even the efficacy when we look at the global statistics around all these. But I know there are lots of concern around the safety and the side effects of the vaccine. And there is ground for this because every vaccine comes with side effects, and when we talk about side effects, it's mostly minors. These are most side effects that will resolve within like a few days, and I want to put it into context, right? When people talk about safety for usual medication like aspirin, 1 to 2% of people in the population will develop allergies to aspirin. That doesn't mean that we need to take aspirin off the shelf because it's still helping like a significant proportion of people around the world globally. Same for penicillin. Around 10% of people will be allergic to penicillin. So these are things that we need to keep in mind when we assess the the different risks that are involved. But then again, to answer your question, Maulana, we need to look at the manufacturer's recommendation for this, and this will be different from vaccine to vaccine as more data comes out.
As somebody actually said, and I didn't manage to check if it's true, but they said one of the listed side effects for Panado is possible death. I didn't actually see if that's true or not. But I think the point that they were trying to make is that you hardly find a modern medicine except that there are a plethora of side effects that one needs to be cautious of. And of course, that is something that needs to be put into context at all times. So shukran for that, Dr. Shameem. There's Tasnim who is currently on mute. If I can just, let me see if I can unmute you. Yes, I can. Okay. There is this notion, I see somebody doing it here as well, saying that, you know what, the recovery rate for the recovery rate for COVID is like 90%. Somebody else says like 97%. I don't know the exact statistics. So why the need for the vaccine? I personally don't like that kind of question. It's kind of undermining the value of human life. But Bismillah, let's hear what are your thoughts on this?
Actually, I think it's a very valid question because that's one of the things that's one of the criteria that Big Pharma will use to assess whether it's really worth producing a vaccine for, because if people are going to recover from it and have lifelong immunity, does it really make financial sense? So it really is a valid question. So when the Zika virus, if I can use that as an example, came out a couple of years ago, there was that same argument, like, is it really worth it because people develop immunity towards it, and it only affects a certain population, and it will only, like in males, it causes nothing. Even it only really causes severe disease in women who are pregnant. So if we're only going to make that vaccine to vaccinate such a small population, does it make sense for the resources, for the scientists, for the time and we're going to put into it? Basically, so those things do play a role in what becomes okay, or how far a vaccine will take to be developed. So if 90% of the population recovers, I'm not really sure if that statistic is actually correct. I think like I said, because it's a moving target, we don't know what we're expecting next. We don't know what kind of a mutation. And the thing is, how many waves are we going to go through before we can figure this out? And this is a pandemic. It's like nothing we've ever seen. If it was localized to a particular geographical area, like one country or one region, other interventive measures would work. For example, strict quarantining. But in this case, because it's so widespread, it is not working. So we can't look at the vaccine in isolation, saying that this is the percentage, so does it make sense? So vaccination is only one aspect of being able to eradicate or control the disease. But obviously, mask wearing, have we ever seen this level of mask wearing in the history of humankind? Or so basically, I don't think there's any getting away from us needing to be vaccinated or developing immunity. Let me go with that term, developing immunity by whatever means, whether it's an exposure, whether it's a vaccine. The question we really need to ask in this case is, how many waves do we want to see? How long do we want to spend indoors? How long do we want our lives to be disrupted for? And that should help us answer whether we want to take a vaccine or not. Because without proper vaccination or some kind of interventive measure, or like a miracle antiviral drug, which I don't see on the horizon anytime soon, we are going to see multiple waves. That's just how a disease progression will actually keep going. So yes, it's not just about deaths, it's also about all the other disruptions that go on in life when even if only 10% of the population is dying, they recover. But look at the devastating effect that it has. Schools have to be closed, businesses have to be closed. There's like people are developing actual psychological issues from having to be indoors, and this is no way to live. That's why we need a vaccine.
People have lost their businesses, their jobs, their salaries, families are going hungry, people are committing suicide.
Exactly.
The list just goes on. And again, like I reiterated before, the loss of one human life that could have been spared is one life too many. Dr. Shameem, I think this one is probably best suited for yourself. The genetic part of this virus, there's a claim that it could be carried over and modify the human gene. Can an honorable doctor please explain how this is understood, or rather, is it wrong or something? Yes, is it wrong? Bismillah, Dr. Shameem.
Yeah, so this is something that is causing a lot of worries in people, that, we're using a piece of genetic information that we are inserting into you, and that will change your genome. Not only you, but like any generation that comes, like your progeny and so forth. And it's completely false. It's completely untrue, because if you understand the basic science of molecular cellular biology, the different processes that myself and Dr. Tasnim we learn, in high school, in undergraduate classes, we know that what we're using does not cause anything as certain people are describing, simply because there are lots of safety nets that are actually put into the design of a vaccine. For example, what a lot of people don't know is that there is a special program that is inserted in those genetic code that we're using now to produce the envelope inside the body, that causes it to actually auto-destruct of the sometimes. That's called a polyethyl. And these are all functions that we know from the normal machinery and the normal processes that happen in a cell, because if you throw an apple in the air, it's gonna fall down, because that's the law of gravity. And basically, the safety that goes and the understanding that goes into how that piece of genetic material that we're using in a vaccine, introducing this into a human, and making sure that it stays safe and that it doesn't cause any form of genetic impact, is proven, and I have absolutely no doubt about that, simply based on the way it works. And the safety net are there across the board. As I told you, it's something that is not long-lived. If you look for it inside the body a few weeks after vaccination, it's completely gone. And for most vaccine, any trace of that genetic material is actually gone within days and not weeks.
Okay, shukran so much, Dr. Shameem. Unfortunately, our time has now completely expired. We are going to have to cut the program. And this is not because we don't want to get to the rest of it. It's simply because we're also on the radio waves, 91.3. To Sister Fatima Isaacs, I did say that I'm not sure I heard from somebody. So I'm not propagating fake news. I was just simply narrating something, and I said, all medications, all Western medications have side effects. I didn't say that it's confirmed that Panado causes death. Especially, I didn't use the word normal dosage. So I'm sorry if you misunderstood there. Shukran, doctors, for the clarity. There are other questions that I would send to you that we've received from the viewers as well. And hopefully we can have some sort of follow-up on that. Jazakumullah khairan for availing yourselves. I know you are very busy on a daily basis. Spoke to Dr. Tasnim today while she was in a lab with all of her protective clothing on, subhanAllah. Dr. Salim Parker, everyone, and all the listeners of the Cape. our viewers on the various platforms. Jazakumullah khairan for joining us at Isnad Academy. We say thank you to our broadcast partner, Radio Voice of the Cape, for sharing this with us, and to all of you for taking the time out to get this information. Please do share it. We will be available on various podcasting platforms as well, including Spotify, Google Podcasts, Apple Podcasts, etc. But until next time, sallallahu ala sayyidina Muhammad, subhanallah wa bihamdi, subhanakallahumma wa bihamdik, nashhadu an la ilaha illa anta, nastaghfiruka wa natubu ilayk. Assalamu alaikum wa rahmatullahi wa barakatuh. Have we ended?
Are we off?
No, it says live still.
Okay, let me confirm for the moment. I have selected end. Okay, we're ending soon if we didn't end yet.
Still says live.
I've got a viewer next to me. I don't think we're live. Are we live? I think we're live. Still.
Okay, if we are still live, we're busy ending, inshallah. We're having a bit of, I see it says having trouble connecting, which is strange because I'm actually trying to disconnect. But I honestly don't think we're live yet. Let me check. If anybody can still see this, send me a WhatsApp to tell me that we're live. Oh, we are live, yes. We are live. We are trying to end the program. It just keeps saying,
I was going to show you the phone now.
Okay, assalamu alaikum wa rahmatullah. Doctors, you can all, you may log off, inshallah, and then we'll be in touch. Barakallahu feekum.